Welcome to today's webinar, and today we're going to focus exclusively on applying linear heat detection to refrigerated warehousing, cold storage, and freezers. If this is the first Protectowire webinar you've ever attended, welcome aboard. If you'd like what you hear today, please note that we have a variety of webinars available on our website, www.protectowire.com, under the Resources tab. There, you can sort the resources to view videos only. The webinars and other introductory videos available explore a variety of topics, from explaining the different types of Protectowire technology to integrating Protectowire into other manufacturers' control equipment. We also cover installation in general, as well as how to protect different types of fuel tanks. Similar to that webinar, this is going to be a more focused dive into a single application. And lastly, if you've previously joined us for any webinars, welcome back. Let's get started. To start off today, we're going to start with a high-level overview of the two main types of suppression systems you will find in refrigerated and freezer warehousing, and how our linear heat detectors integrate into those systems. Everything we're going to cover here today is referencing typical installations. There are always exceptions to every design rule and/or site-specific requirements. So as such, please always check with the local AHJ, authority having jurisdiction, for any approval-related questions or designs. This is most likely a review for most of us on the webinar today, but before we go into any details, we need to cover the basics. Most refrigerated or freezer warehouses have either a pre-action system or a double interlocked pre-action system. In both cases, the sprinkler pipes do not contain water. As we all know, water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. While there are a variety of definitions available to explain the differences between the two systems, the basic summary is this. Pre-action systems utilize a dry pipe sprinkler system, and when an initiating device, such as Protectowire, initiates an alarm condition, a valve is electronically opened and water flows into the sprinkler pipes. Now the pipes contain water and are waiting for a sprinkler head to operate, allowing water to then suppress the fire or heat event. A double interlock pre-action system also uses a dry sprinkler system, but with an additional level of redundancy or protection. This system also requires an initiating device, such as Protectowire, to initiate an alarm condition. However, unlike a pre-action system, water is not released into the sprinkler piping by the activation of a single initiating device. This system also requires a sprinkler head to operate, thereby creating a low air condition within the sprinkler pipes. The combination of an initiating device alarm as well as a low air condition within the sprinkler piping then allow water to begin to flow. Regarding detector placement, specifically linear heat detector placement, we have seen it all. In almost all cases, sprinklers and Protectowire linear heat detection are run at the ceiling level. We have also seen applications where there are only sprinklers in the racks, as well as applications where there is only Protectowire in the racks. How the racks are protected becomes both an engineering design call as well as a local AHJ decision. If you are looking to design, service, or install a system, please check with your insurance company and local authorities to determine any requirements in your area. Now we can move on to choosing the correct Protectowire linear heat detector for your refrigerated or freezer warehouse. Protectowire currently offers 8 different fixed initiation temperatures, ranging from our lowest activation temperature at 135 degrees Fahrenheit or 57 degrees Celsius to our ultra-high 500 degree Fahrenheit or 260 degrees Celsius detector. Today we're going to focus on our XLT series. XLT stands for extremely low temperature. We offer this detection temperature in 2 different technologies, our standard PHSC and our newer CTI technology. I'll discuss these in detail in the next few slides. While we do offer other products with some well-known industry jacketing materials, such as a PVC or a fluoropolymer, our XLT jackets are manufactured with a proprietary outer jacket material that is extremely soft and pliable. This design feature assures survivability at very low temperatures, as this detector type is UL listed and FM approved to minus 60 degrees Fahrenheit or minus 51 Celsius. This detector was designed exclusively for use in refrigerated and freezer warehousing and is not intended for outdoor use. Every digital linear heat detector has a maximum ambient temperature in which it can be applied. Our XLT series is no exception. With the lowest initiation temperature of any digital linear heat detector at 135 degrees Fahrenheit or 57 C, it also has a maximum ambient temperature of 100 Fahrenheit or 38 C and is only recommended for climate-controlled environments. Pictured here is our standard 135 degree Fahrenheit or 57 C detector, the PHSC 135 XLT. PHSC, as I just mentioned in the previous slide, stands for Protectowire Heat Sensitive Cable. This particular product uses two standard spring steel conductors and is a normally open resistive contact device compatible with any IDC or initiating device circuit. This slide depicts the three different operating conditions of our PHSC 135 XLT. In a normal condition, an end-of-line resistor conditions the circuit, assuring the supervisor equipment that all parts of the circuit remain functional. If there is a break in the cable or a compression terminal becomes loose, current flow stops and the supervisory equipment recognizes the open fault and then reports a trouble condition. And finally, as depicted in that third image in the bottom of your screen, when there is a heat event or a fire that meets or exceeds that 135 degree Fahrenheit or 57 degrees Celsius, the heat-sensitive polymers weaken or melt, allowing those metal spring steel conductors to make contact, forming an electrical short. This short then bypasses the end-of-line resistor, causing a change in resistance to the circuit that allows the supervisory equipment to initiate an alarm condition. Featured in this slide is our CTI 135 XLT. CTI stands for, as we mentioned earlier, the Confirmed Temperature Initiation Technology. Please note that unlike the PHSC 135 XLT, which uses two of the same spring steel metal conductors, the two metal conductors in this image are dissimilar metals. The metals shown here actually form a T-type thermocouple, allowing us to determine the temperature at any shorted point on the detector. This technology does require the use of a universally compatible CTM series interface module. This module provides the interface between our CTI series detector and a standard IDC or addressable module. For those of you looking for more information on this technology, as I mentioned earlier, we have a few additional webinars and short introductory videos that introduce it, located under the Resources tab on our website. Unlike standard digital linear heat detectors, our CTI series has four operating conditions. During normal condition, the end-of-line resistor conditions the circuit, allowing the CTM series interface module to know everything is working properly. Note that this image is not displayed on your screen here. Moving on, if and when current flow stops, our CTM series interface module will initiate an open fault or a trouble condition, similar to our standard product. I want to pause and focus on the middle image on your screen here, because this image is what really separates our CTI technology from all other digital linear heat detectors. As I mentioned earlier, using our CTM series interface modules, we can determine the temperature at any shorted point on a CTI detector. This middle image represents a CTI detector that has been damaged. It's been bent beyond its 90-degree bend radius, it's kinked, smashed, etc. When our CTI series detector is mechanically damaged, our CTM module will actively display the location in feet or meters, as well as the current temperature at that shorted point. So for refrigerated and freezer warehousing, this feature is undeniably important. Both pre-action, as well as the double interlock pre-action systems we discussed earlier, require an initiating device to function. When using our CTI series detector with a pre-action system, it significantly reduces the possibility of water being released into the pipes without a heat event. When using our CTI series detector with a double interlocked pre-action system, even with a low air condition, mechanical damage to the detector does not release water into the sprinkler pipes. Mechanical damage only initiates a short fault or trouble condition. And lastly, in the bottom image, similar to our standard PHSC technology, when the detector is exposed to heat at or above its set point, the CTM series module initiates an alarm condition. The module will then also actively display the temperature and location of the fire or overheat. Let's move on to discuss spacing and installation practices. We're going to begin with ceiling detection and work our way down into rack detection. Throughout the balance of this presentation, I'm going to be referencing FM datasheet 8-29. Factory Mutual underwrites a considerable number of these facilities and is a great resource regarding system design. For those of you familiar with datasheet 8-29, I'm sure you appreciate its value. For those of you unfamiliar with this document, I strongly recommend you download it. There's no cost to download the document, and it's a fantastic resource for questions related to refrigerated and freezer warehousing. Section 2.3.3 of the datasheet is a great place for our discussion to start. For all refrigerated and freezer warehouses, FM requires Class A loop circuitry to assure there is detector redundancy in case of a break. Rate of rise detectors are not acceptable because of false alarms due to doors being opened or other abrupt localized temperature changes. The detector should have a lower temperature rating than the sprinkler heads used within the facility, and ideally as low an activation temperature as possible given the ambient conditions. Now, when a facility has smooth ceilings, the Protectowire can be located at the ceiling level up to our maximum listed spacing. For non-smooth ceiling types, the linear heat detector's listed spacing is reduced to 1/2 the maximum detector spacing or the fully allowable sprinkler spacing. Now, typically, the Protectowire is attached to and follows the ceiling sprinkler pipes. We're going to address that directly in a few minutes. As we just discussed, Section 2.3.3.2 of FM datasheet 8-29 references the maximum allowable space for smooth ceilings. For non-smooth ceilings, it references 1/2 the listed spacing or the maximum allowable sprinkler spacing. To provide some context, on your screen is our maximum listed spacing from FM and UL. Our detectors have earned a maximum allowable space from FM of 30 feet or approximately 9 meters, and this is on centers, whereas UL allows for a maximum of 50 feet or approximately 15 meters on centers. For the intent of this presentation, we significantly reduced our listed spacing chart to only focus on our two lowest initiation temperatures, the 135 Fahrenheit, 57 Celsius, and the 155 degree Fahrenheit, 68 degrees Celsius detectors. Please remember that it is often necessary to reduce the detector spacing as the ceiling height increases. Now I want to discuss how and when to install in-rack HADs or heat actuated devices. Typically, a separate detector, such as Protectowire, is required by FM for use with both the ceiling as well as in-rack sprinklers. There are certain circumstances, however, where ceiling detection only is acceptable. Section 2.3.3.3 of datasheet 8-29 further defines these conditions. Separate heat detection is not necessary when the facility has an FM-approved refrigerated area system and the maximum storage height is 35 feet, just under 11 meters, and the maximum building height is 40 feet, or just over 12 meters. Information like this is the reason that we use the word typical so often in the special hazard industry. While the physical measurements of 35 feet and 40 feet are clear, we've seen a variety of interpretations. Some are rather outrageous and others are very literal to find a way to apply subjective interpretations to these objective values. So for example, with a maximum storage height being 35 feet, how is detection designed for a building that has racks up to 40 feet? But maybe they don't use the top 5 feet of the storage. Another example is what happens when a maximum building height is measured to be the distance from the highest point of the racking system, rather than the floor or the ground floor, to the lowest point of the building roof. I bring up these examples to highlight how important it is to understand what is needed from the detection system. There are some additional facility requirements that must be considered if you intend to avoid in-rack detection. The maximum hazard needs to be Class 3, there can be no solid shelves in the racks, and ceiling detection needs to be 1/2 of the listed spacing, but not less than that of the sprinkler spacing. The challenge with a webinar is not being able to see your crowd. I'm sure there are a few of you out there looking at the NFPA 13 reference and the photo of Protectowire with a double loop pipe strap on a sprinkler pipe and you're shaking your head. The interpretation of NFPA 13's clause about non-system components must not be misinterpreted. When Protectowire is employed in a pre-action or double interlocked pre-action system, it becomes a critical component and the controlling portion of a sprinkler system, as it has the ability to electrically release solenoids on valves. Sprinkler system hangers are designed to support 5 times the weight of the water-filled pipes, plus 250 pounds at each point of pipe support. Considering the weight of a 500-foot, about 150-meter length of Protectowire linear heat detector weighs 8 pounds, or just under 4 kilos, this has a negligible loading effect when the detector is supported by the sprinkler piping. I want to be clear, though, that pipe mounting to in-rack sprinklers is not recommended. Regardless of everything we've said here so far regarding NFPA 13, always seek approval from your local AHJ prior to any designs or starting installation. If and or when you can install Protectowire on the ceiling sprinkler pipes, do not use standard zip ties. A standard zip tie can easily be over-tightened and mechanically damage the detector. We offer 3 different size 6/6 nylon, so it's heat stabilized, double loop pipe straps designed specifically to meet the needs of the sprinkler pipe installations. Having spent the last several slides discussing ceiling spacing and installation techniques, let's now discuss in-rack detection. Similar to referencing FM datasheet 8-29 for ceiling positioning, we also recommend following this document for any in-rack spacing. Basically, FM 8-29 datasheet addresses in-rack detection with 2 different parameters. They do single and double row as well as a multi-row. And regardless of the type, the protection concept is similar, with 1 line of Protectowire being located at every line that there's in-rack sprinklers. On your screen in front of you, we have an elevation view of a racking system. Now, this can be considered an oversimplification, so let's discuss it. For in-rack detector installations, the Protectowire company always recommends installing the detector in the longitudinal flue space and attaching it to the horizontal load beam at each sprinkler level. The purpose of suggesting this location is to minimize any risk of mechanical damage from incoming forklifts or other items. Now, in theory, this sounds fairly straightforward, but there are always on-site challenges with finding the balance between offering the required proximity detection of being in the rack with finding a safe space to install the detector. Some of the newer automated racks do not have a flue space, or that space is significantly reduced, In this case, we recommend using some installation creativity, as many of the new racking systems available today will have a reverse channel that you can often locate the detector in, and it protects the detector perfectly. To further clarify how Protectowire can be positioned within the racks of a refrigerated or freezer warehouse, here we have an isometric illustration. The Protectowire is installed on the back of the longitudinal load beam and supported every 3 to 5 feet, or approximately 1 to 1.5 meters, using our JD1 J-clip. A quick note for anyone designing or installing Protectowire or any other digital linear heat detector. If the detector is installed at a typical room temperature of 70 degrees Fahrenheit, which is 21 C, it is necessary to purposefully leave a bit of sag or allow for the detector to slightly dip in between fasteners. When the facility is finally chilled, the cable will contract, reducing the sag in between the fasteners. The amount of sag to be installed in between fasteners is directly related to the temperature at which the refrigerated or freezer warehouse is expected to operate. I'll provide two examples. For a 0 degree Fahrenheit or minus 18 C facility, we recommend leaving a minimum sag of 7/8 of an inch, which is 2.25 centimeters. Whereas for a facility that's going to be minus 40 degrees F or minus 40 C, we recommend a minimum amount of sag as 1 1/8 inches or 2.8 centimeters. If the detector is installed perfectly taut at room temperature, when the facility is finally chilled, the detector and or the supporting fasteners may be damaged as the Protectowire contracts due to the cold. Here we are featuring our newest mounting accessory, the JD1 clip. This fastener has been designed by us to perfectly accommodate the diameter of our linear heat detectors. This fastener is made of a 304 stainless steel and can be either rack mounted or pipe mounted and paired with a stainless steel pipe strap. The advantage of this J-clip is that the fasteners can be installed before the detector and or the detector can be easily removed for any splicing requirements. Given the size and complexity of today's refrigerated and freezer warehouses, there are often thousands of feet or meters of Protectowire per detection zone. If there is mechanical damage to the detector, being able to easily splice in a small replacement piece is a necessary convenience. Earlier, we discussed the PHSC 135 XLT detector. This is our standard detector and is a universally compatible, normally open resistive contact device. If or when you're required to splice this detector, the process for splicing is quite simple, as you can see here. The first step is to remove a small portion of the outer jacket and heat-sensitive polymers. With the metal conductors exposed, you can bend them gently and slide them into a Euro-style compression terminal, or our PWSC. You must always use compression terminals with all Protectowire detectors. After the detector has been inserted and tightened into the PWSC compression terminal, the splice is then wrapped with our SFTS sealant tape. This is a moisture-resistant tape that seals the splice. Finally, the SFTS sealant tape is covered with an electrical tape for additional protection from the environment. Splicing our CTI series detector follows many of the same principles but uses a different compression terminal. Once again, the first step is to remove a small portion of the outer jacket as well as the heat-sensitive polymers around the metal conductors. Next, gently bend and then insert the polarity-sensitive conductors into the blue CTIC splicing connectors. One of the CTI series detectors conductors is a copper color while the other one is a silver color. Our CTIC splicing connectors have matching compression terminal colors to identify and simplify polarity. Our CTIC splicing connectors are T-type thermocouple rated to assure that all connections on the CTI series circuit remain a T-type thermocouple and eliminate the chance for any parasitic junctions. Standard Euro-style compression terminals used in the PHSC, or were shown in the slide previously, cannot be used with our CTI technology. Once the CTIC compression terminals have been fitted into the detector, the male and female ends are then brought together. Finally, the last two steps with this are identical to our standard PHSC product, where we use an SFTS sealant tape to protect it from the environment, and we cover that SFTS tape in an appropriately rated electrical tape. Both types of Protectowire, the PHSC series as well as our CTI series, have a consistent format for their outer jacket printing as shown here. There are small changes to account for different model numbers and jacketing materials. However, because we are an ISO 9001 registered company, each detector has the lot number printed every 24 inches, or approximately 60 centimeters, and there is also an incremental length mark at the end of the reoccurring print job. I highlight this information as it is remarkably helpful for facility owners as well as field service technicians to understand exactly how much detector is on a particular zone. So we recommend recording the length of each zone during the initial commissioning process, as that can be very helpful later when troubleshooting. Further, certain Protectowire control equipment is available with an alarm point location meter. This meter will help you determine where the detector is shorted. The short can then be easily located using the incremental distance markings on the outer jacket. Knowing the exact length and location of each zone can also help you to create a facility zone map. This is an example of a simple facility zone map for a refrigerated or freezer warehouse with rack storage. One of the largest benefits to having Protectowire within the racks is the fast response provided through the proximity detection. Once the detector activates, knowing where the overheat is located within a facility is very beneficial. Zone maps can be a simple graph or table with rack numbers and distance markers, or they can be a really sophisticated annunciator. Regardless, the linear heat detection technology has the ability to provide hotspot location, so having even a basic zone map can be very helpful for locating an alarm as well as troubleshooting any short faults. Today, we exclusively focused on refrigerated and freezer warehousing, but this slide universally applies to Protectowire. Complying with NFPA 72 testing and maintenance is remarkably simple. Given our products are defined as a fixed temperature, non-restorable line type detector, there is no requirement to perform a heat test per NFPA 72. Despite this, if anyone would like to see a functional test performed, we advise installing an additional service loop near the end-of-line device. This will allow the service loop to age in the same environmental conditions as the balance of the zone. You can then heat test a small portion of the service loop and then reconnect or splice the detector and complete the balance of your inspection and testing. Just be sure that all solenoids and auxiliary functions are disconnected during the testing of Protectowire. We do not want any unwanted discharges, releases, shutdowns, or signaling. Having just discussed the NFPA 72 annual requirements for testing Protectowire, I want to now turn to the practical advantages of using Protectowire. With Protectowire, you can locate the end-of-line box and short out the detector. Within refrigerated and freezer warehousing, there are multiple challenges to testing and inspections. First and foremost, being temperature. Minimizing your time in the freezer is important. Further, there are also high ceilings and often intricate rack designs that you must work around. Using a spot detector of any kind in this environment can become a very significant challenge for any type of testing and maintenance requirements. This last slide on the topic of testing and maintenance is designed to highlight how you can reduce and simplify testing and inspection time through some creative design and engineering. Here you can see 3 different Protectowire zones have their end-align box with a test switch conveniently located just above a standard door. Locating the end-align boxes here eliminates the need for any kind of scissor lift. I do want to clarify that the conduit leading to each junction box contains extension cable rather than linear heat detection cable. This prevents 3 different zones from overlapping in such a small space. Now, let's quickly review some installation photos to apply what we have just learned and discussed. In this slide, you can see the Protectowire is strapped directly to the in-rack sprinkler piping. While it appears as though the installation has used our double loop pipe straps, that's about the only thing that is correct in this photo. As mentioned earlier, Protectowire does not recommend putting our linear heat detector on the in-rack sprinkler piping. With a pre-action or double interlock pre-action system, we're looking for 2 things to happen: an alarm from your initiating device as well as a low air condition in your pipes. If a pallet falls out of a rack and damages the sprinkler piping as well as hits the standard Protectowire, you could have both conditions necessary to put water into those pipes. We use this slide to highlight now how and where we would recommend putting the Protectowire. We recommend the longitudinal flue space on the back of the horizontal load beam, so it's better protected from pallets in the racks and from falling objects in the flue space, with a lower profile closer to the load beam. In many cases, for ceiling detection, the Protectowire is attached to and parallels each sprinkler branch line. At the end of each branch line, the detector is gently turned, maintains our 2.5 inch or 6.4 centimeter bend radius across and moves to the next adjacent branch line and then proceeds back in the opposite direction. Occasionally, however, there's not another branch line to turn toward. In this case, the detector should have cable ties at each end of the piping, allowing it to create a minimum of 5-inch detector loop in the open air. This image certainly violates the 2.5-inch bend radius and may have mechanically damaged the detector. Unlike the last image, this image shows exactly how you make a loop at the end of a branch line using the double loop cable ties and still maintaining that 2.5-inch bend radius or just over 6 centimeter bend radius. On the screen in front of you, both the ceiling and sprinkler pipes have been painted. In accordance with our third-party approvals, the 190 Fahrenheit or 88C detector, which has a white outer jacket, was installed after everything else was painted. You cannot paint Protectowire. Earlier in the presentation, we discussed installing Protectowire on ceiling sprinkler pipes. This is a good image of that. You find that the detector is appropriately supported by the double loop pipe straps with a small amount of sag. The detector is not hanging overly low or pulled too taut. The challenge with sharing application photographs of Protectowire is that it can be difficult to locate a product that is only 4 millimeters in diameter. To make this easier, we've added 2 arrows in this image in front of you. The top arrow points to a service loop installed in the rack. You can see the small coil of cable on the outside of the rack at the top. We discussed the concept of having a service loop for testing purposes earlier in this presentation. Next, as Protectowire recommends, you'll find the detector is located in the flue space of the rack, but it is not attached to the sprinkler pipes. As the detector transitions from the service loop at the top of the rack to be in the flue space with adjacency to the in-rack sprinklers, it makes a gentle bend, highlighted by the second arrow, and does not violate the 2.5-inch minimum bend radius. Lastly, the detector follows the longitudinal support beam of the racking and remains adjacent to the sprinkler pipe and sprinkler heads throughout the flue space. This is a good image to end our presentation with, as it shows one run of Protectowire for every line of in-rack sprinklers, as required by FM datasheet 8-29. Well, this concludes today's presentation. Thank you to everyone who has attended and has been with us this time. If you do have any questions related to Protectowire, freezers, additional warehousing, anything else, please email us at info@protectowire.com. A reminder that you will be receiving a link to this recorded version of this so you can review it, as well as there are additional webinars and other information on our website under the Resources tab for webinars and videos. Thank you.